Hi everyone, welcome back to A207, Data Communications and Networking. We are now at Chapter 8, and in this chapter, we discuss cryptography. My name is Nuruddin, and with me is our A207 student, Matthew Tan.
Hi everyone.
Matthew, what's the first thing that comes to mind when you think of cryptography?
I'm not too sure. Maybe it's some secret code or code breaking?
Well, here's the answer. Cryptography is a tremendous tool and the basis for many security mechanisms. It is not the solution to all security problems. It is not reliable unless implemented properly, not reliable unless used properly, and it is not something you should try to invent yourself unless you spend a lot of time becoming an expert or you subject your design to outside review. And that's just the start of cryptography. The first goal of cryptography is certainly to provide a means of secure communications. The second goal is to turn that same security to protecting software-based assets such as files and data, not just communication sessions. We now look at symmetric cryptography, which assumes that all parties involved already share a secret key. With secret keys, there are two main methods of encryption. One is single-use key, and the other is multi-use key. Both methods have their uses. Single-use keys are mainly for encrypting single messages, such as encrypted emails. Multi-use keys are used where a series of messages needs to be kept together for some reason, so the same key is used to encrypt the entire series. SSL is an area where multi-use keys are employed. Pre-distribution of public keys. Now, the algorithms to generate a matched pair of public and private keys are publicly known, and the software that does it is widely available. So for example, if Alice wanted to use a public key cipher, she could generate her own pair of public and private keys, and keep the private key hidden, and publicize the public key. But then, how can she publicize her public key, and assert that it belongs to her in such a way that other participants can be sure it really belongs to her? Pre-distribution of public keys. A complete scheme for certifying bindings between public keys and identities, that's what a key really belongs to whom, is called a public key infrastructure, PKI. For example, if Alice and Bob are individuals who know each other, then they could get together in the same room, and Alice could give her public key to Bob directly, perhaps on a business card. One of the major standards for certificates is known as X509. This standard leaves a lot of details open, but specifies a basic structure. A certificate clearly must include the identity of the entity being certified, the public key of the entity being certified, the identity of the signer, the digital signature, and a digital signature algorithm identifier, which is a cryptographic hash which uses a cipher. Certification authorities. A certification authority, or certificate authority CA, is an entity claimed by any party to be trustworthy for verifying identities and issuing public key certificates. There are commercial CAs, governmental CAs, even free CAs. To use a CA, you must know its own key. You can learn that CA's key, however, if you obtain a chain of CA-signed certificates that starts with a CA whose key you already know. Then, you can believe any certificate signed by that new CA. Here are some examples of key pre-distribution: SSH, PGP, IPsec, wireless security, transport layer security, for example TLS, SSL, and HTTPS. All previous security measures cannot prevent a person from sending a harmful message to a system. To control access to a system, we need firewalls. A firewall is a device, usually a router or computer, installed between the internal network of an organization and the rest of the internet. It is designed to forward some packets and filter, not forward, others. A firewall can be used as a packets filter. It can forward or block packets based on the information in the network layer and transport layer headers, that is, the source and destination IP addresses, source and destination port addresses, and type of protocol. A packet filter firewall is a router that uses a filtering table to decide which packets must be discarded, which means not forwarded. The packets filter firewall is based on the information available in the network layer and transport layer headers, that is, the IP and TCP UDP headers. However, sometimes we need to filter a message based on the information available in the message itself, that is, at the application layer. Now that sums up our discussion on cryptography. Remember to post any questions onto Google Classroom. Work hard, work smart, work your way to your dreams.